Here is another example. The example says the first, second, and the last term of a GP are 3, 6, and 768. Find the number of tens in that sequence. So, in dealing with this question, first of all, let's look at something in this in the question. Let's look at something in the question. The first, second, and the last term. So, what this statement means is that the first term is 3, the second term is 6, while the last term is 768. So, this is just a way of writing something like this. First term, second term, then 768. First term, second term, last term. Now, we are going to find the number of 10. Because from here, you discover that this is first term, third term. There are numbers in between these 6 and the last 10. So, we don't know the number of 10. So, we are going to look for the number of 10. To look for the number of 10, the first term is A and is 3. The second term is 2. So, if we know the first term and the second term, it means that we can determine the common ratio. To get the common ratio, you simply take the second term, divide it by the previous number, which is the first term. Say 6 divided by 3 is equals to 2. So, the common ratio is 2. Here, having known that the common ratio is 2, this is the last term. So, I will say UN equals to A arrow n minus 1. This UN will stand for the last term. So that I will say 768 equals to A. What is A? The first term, and it's 3. We'll say 3 times arrow, the common ratio, and it's 2. 2 raised to power n minus 1. N minus 1. Then the next thing is to make the 2 raised to power n minus 1 the subject. Therefore, 2 raised to power n minus 1 is equals to 768 divided by 3. 2n raised to power 1 is equals to 768 divided by 3 will give me 256. Now, having done this, you discover that this right hand side of the left hand side of the equation is in index form, while the right hand side of the equation is in ordinary form. So, we have to write this number now to be in index form, being that here is in index form with a base of 2. This one will also be written in index form with a base of 2. 256 is 2 raised to power 8. I will say, therefore, 2n minus 1 is equals to 2 raised to power 8. Now I have both sides of the equation now are now in index form with a base of 2. Knowing that, the next thing for us to do, we will have to equate the index, because the n is index. So we equate the index, 8 is index, n is index, we equate them. We have n minus 1 is equal to 8. n minus 1 is equal to 8. Therefore, n is equal to 8. Taking this minus 1 here, crossing the sign of equality becomes plus 1. N is equals to 8 plus 1 is equals to 9. So, the number of 10 in this sequence is 9. So, there are 9 10 in this sequence.